All right, let's pull back the curtain on the magic that makes our digital world feel so, well, alive. We're diving deep into real-time communication.
I mean, really, have you ever stopped to think about it? You type a message, and poof, it's on your friend's screen halfway across the world. You drag something in a design file, and your whole team sees it move in perfect sync. How in the world does that actually happen?
Well, it's the secret sauce behind pretty much every app we can't live without. We're talking about the instant pings on WhatsApp, that crazy collaborative energy in Figma and Google Docs, the live price tickers on Robinhood, and of course, the split-second action in your favorite multiplayer games. This isn't magic. It's just really, really cool technology.
Okay, let's get into it. The core idea that makes all this possible, well, it's a huge deal in system design.
It's called real-time communication, or RTC. And here's the thing. It's a total departure from how the internet used to work. We used to live in this request and response world. You'd click a link, ask the server for a page, and the server would send it back. With RTC, that connection stays open. The data is pushed to you the second it's ready. No more hammering that refresh button ever.
So how do engineers actually pull this off? Well, they don't have just one tool, they have a whole toolkit. We're about to meet the 5 heavy hitters, the key protocols that make all of this a reality.
First up, we've got WebSocket. The best way to think about this is like one of those old-school pneumatic tube systems you'd see in a bank or an office. You can pop a message in the tube and, whoosh, send it to the server. And crucially, the server can send one right back to you through the very same tube at any time. It's a true two-way street, a full duplex conversation.
Next is server-sent events, or SSE. Now this is less of a conversation and more of a broadcast. Picture a news ticker scrolling along the bottom of your TV screen. The station sends out updates, and you just receive them. You can't shout back at the ticker, right? It's a one-way street, strictly from the server to you.
Then we have long polling. Okay, this one is kinda clever, but it's really a bit of a hack. Imagine you send a courier to a warehouse and tell them, hey, don't come back until a package shows up for me. So the courier just waits, and the second something arrives, they sprint back to you. It works, but you can see how it's not exactly the most efficient system.
Now for something a little different, MQTT. I want you to think of this as a central post office, but for tons of tiny messages. It's not about one-to-one chats. Instead, you have all these little devices, think smart home sensors, that publish messages to a central broker, which is our post office. Then other devices can subscribe to the topics they care about and get the mail. It's super lightweight, which makes it perfect for the Internet of Things, especially on unreliable networks.
And last but not least, WebRTC. This one is all about the direct peer-to-peer connection. Think about a video call. Once you're connected, your computer is talking directly to your friend's computer, sending those heavy audio and video streams back and forth without a big server in the middle slowing things down. It's all about cutting out the middleman for super low latency.
All right, so we've met the players. Now, let's put them in the ring, head-to-head, to really see where each one shines. This is where those critical system design trade-offs start to become really clear.
So the absolute first question you always have to ask is this: does the data need to flow both ways? Is it a conversation or a lecture? On the left, you've got your bidirectional powerhouses, WebSocket, MQTT, and WebRTC, where anyone can talk at any time. And on the right, you have the unidirectional specialists, SSE and long polling, where the server does all the talking.
And this table right here, this is gold. It lays out all the trade-offs beautifully. Let's just walk through it. Look at WebSocket at the top. It's two-way, perfect for chat and games, but look at that scaling difficulty, medium. Why? Because you're holding a live open connection for every single user, and that can get really resource hungry. Now contrast that with SSE right below. It's one way, awesome for notifications, and scaling is low. It's so much simpler because you're just pushing data out. Then you get the specialists. MQTT is also low difficulty to scale because that central broker is designed to handle this kind of traffic. But look at WebRTC, high. Now wait, why is it high if it's peer-to-peer? Well, because setting up and coordinating all those direct connections, that's a process called signaling, is actually a really complex problem to solve at scale.
Okay, theory is great, but let's get practical. Let's turn this into an actual playbook. This is the stuff you need to know for your next project or, your next big system design interview.
This is the million-dollar question, isn't it? You've got a problem that needs live updates. You've got these 5 tools in your belt. Which one do you reach for? Well, let's break it down by use case.
Look, if you're building a chat app, a multiplayer game, or a real-time financial dashboard, just stop here. The answer is almost certainly WebSockets. The reason is simple. You absolutely need that constant two-way dialogue, and it has to be lightning fast. Any noticeable lag and the entire experience just crumbles. But what if you just need to push information out one way? Think about a live news feed, updating sports scores, or maybe system alerts. The user isn't talking back, they're just listening. In this case, server-sent events are your best friend. They are so simple, super efficient, and designed for exactly this kind of one-way data stream.
Now, for our specialists. If you're dealing with a swarm of low-power sensors or devices that might be on a shaky network, MQTT is the undisputed champion. It was born for this stuff. And if you're building the next big video conferencing app, you're going to need the peer-to-peer muscle of WebRTC to stream all that audio and video with the lowest possible latency.
And finally, what about our old friend long polling? You should really think of this as your fallback, your plan C. If you are stuck with old infrastructure that can't handle WebSockets, or you have to support some ancient browsers, yeah, long polling will get the job done. But just be honest with yourself and everyone else that it's a compromise, not the ideal choice.
Okay, that was a whirlwind tour, I know. So let's boil it all down to the absolute essentials. What are the key things you need to remember from all of this?
Here it is, the stuff that really matters. 1. Real-time communication is the very heartbeat of modern apps. 2. WebSocket is your powerful go-to workhorse for anything interactive and two-way. 3. SSE is your lean, mean, one-way broadcasting machine. 4. Don't forget the specialists, MQTT for IoT and WebRTC for media. And finally, and this is the big one, choosing between these is not a minor detail. It is a fundamental architectural decision that will shape your entire system.
So that's what it all comes down to. The next time you're staring at a whiteboard, designing a system that needs to feel instant, you now have the playbook. You know the questions to ask and the trade-offs to make. So, what's it going to be?